Welcome back to Homework Help with Miss Gore. Today we're going to be talking about our Unit 6, Day 3 homework. We are graphing exponential functions with and without restricted domains. So in question 1, we are to graph the function 2 to the power of x plus 3. And our domain is restricted. So what I want to do is I want to put into my calculator 2 to the power of x plus 3. And I want to take a look at my table. So when I take a look at my table of values, what I want to do is I want to have a column for my x and a column for my f of x, or my y value. So it says to go from -4 to 2. So -4, -3, -2, -1, 0, 1, and 2. I also do want to note that both of these will be closed circles. So when I'm graphing my restricted domain, I want to make sure I'm starting and ending with a closed circle. So using my graphing calculator, I get 3.0625, 3.125, 3.25. And again, just taking these, 3.5, 0 is 4, 1 is 5, and 2 is 7. So all I'm going to do now is I'm just going to plot those points. So -4, I'm going to approximate a little bit above 3 there. -3 also, maybe just a little bit higher than that one. -2, a little bit higher. -1 right there in the center. 0, 4, 1, 5, and 2, 7. I'm going to connect those with a nice curve. And then I'm going to label that with my f of x equals 2 to the x plus 3. All right, so my domain was given to me. And it says to use my domain in writing this in interval notation. So in interval notation, I'm going to be using closed brackets. And I'm going to say that this goes from -4 to 2. And again, close my bracket. Now my range. When I'm looking at my range, I'm looking for my lowest y value versus my highest y value. So my lowest y value from my table, 3.0625. My highest value, 7, again, using closed brackets because they are both closed circles. All right, moving on to number 3. We have -4 to the power of x. Notice this is not in a parenthesis. So this does tell us that what's going to happen to my graph is that it's going to flip over my axis. So even though there is no restricted domain, I do want to include a table of values. So x, and in this case I have a g of x. So looking at my table, I'm going to look for some points that might be really nice to plot. So I'm going to start with -2, and -2 is -0.0625, -1, -0.25, 0, -1, 1 is -4, and 2 is all the way down at -16, which I'm not going to get on my graph. I'm not going to change my scale here, but I'm just going to plot my points there. So -2, down slightly, -1, slightly, 0, -1, 1, -4, and I know that this exponential equation will never ever cross my x-axis. It will continue on infinitely in both directions. So my g of x, -4 to the power of x. So my domain here. So my domain had no restrictions on it. There are no holds on those x values, no holes, no gaps. So my domain for this is -infinity to infinity. And I always put parentheses around my infinities. Now my range. I'm going bottom to top. Now I'm looking at the bottom here, and I'm seeing that this is going to go on forever and ever and ever. So my lowest value, -infinity. Now I'm traveling up, traveling up, traveling up, and I'm looking at right over here. What is the behavior at this part? So I'm looking at this, and I know that there is no way this is ever even going to touch my x-axis. It's going to get pretty close, though. So I'm going to say that it approaches 0, but I'm going to use an open parenthesis here to show that it's not actually going to touch my 0. All right, Moving on to the back. Again, just pay attention. I do want you to notice that this is not a misprint. This is not a misprint. Okay, you can graph that one on your own. And I do want to talk about number 7. So in number 7, I have what is the difference between the graphs y equals 2 to the x and y equals 2 to the negative x. So if I take a coordinate plane, little xy axes there, and I plug these into my graphing calculator and I get a rough sketch here. So in a rough sketch, this is going to look somewhat like this one. And when I put a negative in front of it, it's going to look something like that. So I want to know what is the relationship between these two graphs. So if I were to have these on the same set of axes, they kind of look like a mirror image. So what they are is this is a reflection, like in a mirror, over the x-axis. All right, hopefully that helped you with your homework, and I will have a great day, and I'll see you tomorrow.